Determine f 10,001 of x for the function f of x equals cosine 2x, then evaluate f 10,001 at pi over 8. F of x here is cosine of 2x. The derivative, f prime of x, will therefore be negative sine, leave the inside alone, multiplied by the derivative of the inside to complete the chain rule. That 2 moves to the front with the negative, and we have negative 2 sine 2x. The second derivative, f double prime of x, will be the negative 2 comes along, the derivative of sine is cosine, leave the inside alone, multiplied by the derivative of the inside to complete the chain rule. That 2 will move out front with the negative 2. But instead of calling it 4, I'm going to call it 2 squared so that we can discern a pattern here, and then times that cosine of 2x. The third derivative will be negative 2 squared. The derivative of cosine is negative sine, leave the inside alone, and then multiply by the derivative of the inside to complete the chain rule. We have a double negative, so we'll end up with a positive. 2 squared times the 2, which will move out front with it, will be 2 cubed, and we have sine 2x. The fourth derivative will be the 2 cubed comes along. The derivative of sine is cosine, leave the inside alone, but then multiply by the derivative of the inside to complete the chain rule. I can move that 2 out front with the other 2's, and I will have 2 to the 4th cosine 2x. So it's the fourth derivative that will return back to a positive cosine, just like the original function. But it has a 2 to the 4th in front of it, and we'll have to account for that. We want to try to find a pattern result here. Now, every fourth derivative, I can see it's returning to a positive cosine of 2x, but it also has a coefficient in front of it, and we'll want to determine what that coefficient is. Well, it's certainly positive, but the first derivative has a 2, the second derivative has a 2 squared, the third derivative has a 2 cubed, the fourth derivative has a 2 to the 4th. And therefore, the 4n derivative will have a 2 to the 4n. It matches the order of derivative that you're taking. A 2 raised to the 4n power, and it will have returned to a positive cosine due to the pattern every fourth derivative. And this is where n is a positive integer. So we can use this pattern to try to determine the 10,001st derivative of f of x. Well, 10,001 is not divisible by 4, however 10,000 is. So what I can do is take the 10,000th derivative and then take one more derivative by indicating a prime outside the square brackets. The 10,000th derivative, being divisible by 4, will make use of this formula here. And it will be 2 raised to the 10,000, and then it will have returned to a positive cosine of 2x. And then we want to take one more derivative beyond there so that we have the 10,001st derivative. Well, the derivative beyond there, the 2 to the 10,000, is all just a constant. It comes along. The derivative of cosine is negative sine. Leave its inside alone and multiply by the derivative of the inside to complete the chain rule. There's no more derivatives left. I'm just going to collect together. The negative will move to the front. I have 2 raised to the 10,000 times one more 2, so it'll be to the 10,001, and I have a sine 2x. There is our 10,001st derivative of x. The next thing to do is to evaluate this at pi over 8. So f 10,001 of pi over 8 will be, we have the negative 2 to the 10,001, and then we will have sine of 2 times pi over 8, or 2 pi over 8. So we have negative 2 to the 10,001. Sine of 2 pi over 8 can reduce to pi over 4. So we have negative 2 to the 10,001 times the sine of pi over 4 is root 2 over 2. And this gives us a negative 2 to the 10,001 square root of 2 over 2. Since we have a 2 in the denominator, we can divide it into the 2 to the 10,001 in the numerator by subtraction of exponents. This is 2 to the 1. And 10,001 minus 1 is 10,000. So we can write this as negative 2 to the 10,000 times the square root of 2.